Tired of feeling lost in AI conversations? Here's my bold promise. Spend the next 50 minutes with me, and I'll transform you from an AI beginner to the go to AI expert in your circle. Hey everyone, welcome to the AI News, your source for understanding the rapidly evolving world of artificial intelligence. Before we dive into daily AI news and breakthroughs, we're going to build a strong foundation together. In this special series, we're breaking down 101 essential AI terms that you'll hear everywhere, from news headlines to tech conversations. What makes this glossary special? Each term comes with a clear, straightforward definition, an explanation that relates to your daily life, the latest industry developments showing why it matters right now. Here's the best part. We've carefully arranged these terms in order of complexity. We'll start with the absolute basics that everyone should know, then gradually progress to intermediate concepts, and finally explore advanced topics that even tech enthusiasts find fascinating. Ready to begin? Let's dive into our first term. Data is raw facts and information collected for reference or analysis, including numbers, text, images, sounds, and other forms of information that can be processed by computers. Let me break this down for you. Think about your day so far. Every time you checked your phone, sent a text, or took a photo, you were creating data. It's the fundamental building block of all AI systems. Do you know? Microsoft's AI data centers process 8 exabytes of data daily. It clearly shows how crucial data has become. It's like having a digital library that grows larger than all human knowledge every single day. Artificial intelligence refers to computer systems designed to simulate human intelligence, capable of performing tasks that typically require human cognitive abilities, such as learning, problem solving, and pattern recognition. In simpler terms, we're teaching computers to think and make decisions like humans do. Remember those science fiction movies where computers could understand and interact with people? That's exactly what we're building now. Looking at Claude 3's recent achievements, we're seeing AI systems that can actually match human experts in complex tasks. It's not science fiction anymore. An algorithm is a precise sequence of computational steps that transforms input into output, following a set of rules to solve specific problems or perform defined tasks. Here's why this matters. Imagine following a cooking recipe where every tiny step is spelled out perfectly. That's an algorithm for computers. While we might occasionally improvise in cooking, algorithms follow their instructions exactly, every single time. And as we can see from Google's recent breakthrough, these digital recipes are becoming incredibly efficient, doing more while using less resources. Machine learning is a subset of AI that enables systems to automatically learn and improve from experience without explicit programming, using statistical techniques to find patterns in data. This is revolutionary because it changes how we teach computers. Instead of writing every single rule, we let them learn from examples, just like how you learn to ride a bike. You didn't study physics equations, you practiced and improved. Tesla's self-driving cars are a perfect example. They've learned from millions of miles of real driving experience, potentially becoming even safer than human drivers. An AI model is a specific implementation of AI algorithms trained on data to perform particular tasks, containing learned patterns and parameters that enable prediction or decision making. Think of each AI model as a digital expert trained for a specific job. Just like how you might consult a doctor for medical advice or a mechanic for car problems, different AI models specialize in different tasks. AlphaFold 3's breakthrough shows the incredible power of specialized AI models. It solved one of biology's greatest challenges by predicting protein structures that would take scientists years to figure out in a lab. This is literally accelerating medical research and drug development by years. Training is the process of teaching an AI system to make accurate predictions by feeding it data and adjusting its parameters based on performance feedback. This is just like teaching any skill, but at a massive scale. Imagine teaching someone to identify dogs by showing them thousands of dog photos, giving feedback on each guess. The exciting part is how efficient this process is becoming. Meta's breakthrough means what used to take months and cost millions can now be done in days for thousands. It's like finding a way to compress years of learning into just a few hours. A dataset is a structured or unstructured collection of data used to train and test AI systems, organized for optimal machine learning algorithm processing and validation. Think of a dataset as the AI's textbook, but much more comprehensive. To teach AI about the world, we need to show it millions of examples. Google's Common Sense dataset is revolutionary because it's teaching AI about everyday situations. It's like giving AI a crash course in human common sense. improving its understanding of our world by 40%. Input is information provided to an AI system for processing, including text, images, audio, or any data format the system is designed to analyze. Every time you speak to Siri or type a question to ChatGPT, you're providing input to an AI system. What's exciting now is how sophisticated this has become. Apple's latest advancement means your device can understand and process your input instantly. It's like removing the language barrier between humans and machines completely. Output is the response, prediction, or result produced by an AI system after processing input data through its trained models and algorithms. This is what you get back after AI processes your request. Could be an answer, a decision, or a generated image. The quality of AI outputs has reached an incredible milestone with Midjourney's latest version. We're not just talking about faster responses anymore. We're talking about AI creating images that professional photographers can't distinguish from real photos. This shows how AI outputs have evolved from simple responses to creating content that matches and sometimes exceeds human capabilities. Pattern recognition is the automated detection of patterns, regularities, and relationships in data, enabling AI systems to identify trends and make predictions. This ability is crucial because it's how AI makes sense of massive amounts of information. While humans are great at recognizing patterns in things we can see or hear, AI can find patterns in millions of data points simultaneously. Amazon's fraud detection success shows the power of this capability, spotting suspicious patterns across billions of transactions to save customers $2 billion. It's like having a security guard who can watch a million security cameras at once. Prediction is the output or forecast made by an AI system based on patterns learned from training data, estimating likely outcomes for new, unseen situations. Think of AI prediction like a weather forecaster who's studied weather patterns for decades. But imagine this forecaster can analyze millions of patterns instantly. That's what makes Google's DeepMind achievement so incredible. It's now warning us about dangerous weather events before they happen, potentially saving countless lives. It's like having a superpowered crystal ball that actually works. Accuracy is the ratio of correct predictions to the total number of predictions made by an AI system, measuring how well the model performs across all classes or outcomes. This is simply about getting things right, like your batting average in baseball. What's remarkable about Microsoft's medical AI system isn't just that it's accurate, it's that it's more accurate than human doctors. Imagine catching cancer early 98% of the time. That's not just a statistic, it's about giving people better chances at survival. Error is the difference between an AI system's prediction and the actual correct result, indicating where and how the system makes mistakes. Everyone makes mistakes, even AI. The key is understanding and reducing these errors. Meta's breakthrough is particularly exciting because it addresses one of AI's biggest challenges: hallucinations, or making up false information. It's like having a fact checker built right into the AI's brain, making it much more reliable for real world use. A neural network is a computing system inspired by biological brain structures, consisting of interconnected nodes that process and transmit information. Imagine your brain's network of neurons, but recreated digitally. Each connection helps process information, building understanding piece by piece. IBM's achievement is game changing because they've found a way to make these digital brains work with far less energy. It's like getting all the power of a supercomputer while using the electricity of a light bulb. Deep learning is a subset of machine learning using multiple layers of neural networks to process complex patterns and extract high level features from raw data. Think of deep learning as giving AI the ability to understand things in layers, like how you understand a movie through its plot, characters, dialogue, and visual effects all at once. DeepMind's system playing 1000 games simultaneously is mind boggling. It's like having someone who can master chess, poker, and soccer all at the same time. Training data is the collection of examples used to teach an AI system, including both input information and correct outputs for supervised learning. This is kind of homework we give to AI, the examples it learns from. Anthropic's breakthrough is like finding a way to teach someone a language in half the time with fewer examples. They figured out how to make artificial intelligence learn more from less, which makes developing new AI systems faster and more efficient. Testing data is a separate set of examples used to evaluate an AI system's performance on new unseen data after training is complete using the training data we discussed previously. Think of this as the final exam for AI. We need to make sure it can handle new situations, not just memorize answers. Stanford's new testing framework is crucial because it helps us catch biases. It's like having a super thorough teacher who ensures the AI is being fair to everyone. A label is the correct answer or classification assigned to training data, used to teach AI systems to make accurate predictions. Think of labels like name tags at a huge conference. They tell us exactly what or who something is. When teaching AI to recognize cats and dogs, each training image needs a label saying, this is a cat or this is a dog. Manually attaching these labels to millions of images used to be like having to name tag every grain of sand on a beach. That's why Google's auto labeling breakthrough is so important. It's like having an assistant that can instantly and accurately put name tags on everything, especially crucial for medical images where precision is vital. This means hospitals can build specialized AI systems much faster, potentially speeding up disease detection and diagnosis. Supervised learning is a type of machine learning where the AI system learns from labeled examples, with each input paired with its correct output. This is like learning with a teacher who shows you the right answer for every question as part of the learning and training. Amazon's success shows how powerful this can be. They've essentially created a quality control inspector that never gets tired and catches almost every defect. It's revolutionizing how we ensure product quality. Unsupervised learning is a type of machine learning where AI finds patterns and relationships in data without labeled examples or specific guidance. This is more like letting AI explore and discover on its own, like a curious child finding patterns in the world around them. Spotify's discovery of new music genres is fascinating because the AI found patterns that even music experts hadn't noticed. It's helping us understand human culture in new ways. Natural language processing is a branch of AI focused on enabling computers to understand, interpret, and generate human language in a way that is both meaningful and useful. Think about all the ways you use language in a day: talking, texting, reading, writing. NLP is about teaching computers to handle all of that. Microsoft's breakthrough in medical settings shows just how far we've come. Imagine a doctor being able to focus completely on their patient while the AI captures and understands every important detail of the conversation. It's like having an incredibly skilled medical scribe who never misses a word. Computer vision is the field of AI that enables computers to understand and process visual information from the world, including images, videos, and real time visual data. We're teaching computers to see and understand the world just like we do. Tesla's advancement with emergency vehicles is particularly impressive because it works in conditions where even human eyes might fail. Think about driving in heavy fog or rain. Now AI can spot emergency vehicles even when we might miss them. This isn't just clever technology, it's technology that's actively making roads safer. A transformer is a neural network architecture that processes sequential data by focusing on relevant parts of the input through attention mechanisms, revolutionizing natural language processing. Think of a transformer like a super smart reader who can instantly connect related ideas even if they're pages apart. It's the breakthrough that powers most modern AI systems. Google's Palm 3 shows just how powerful this is. It can understand and connect ideas across hundreds of languages, like having a universal translator from science fiction. The attention mechanism allows AI models to focus on the most relevant parts of input data, similar to how humans concentrate on specific details in a scene or text. Just like how you can instantly focus on your name being called in a crowded room, attention mechanisms help AI focus on what's important. Meta's breakthrough means AI can now maintain focus across entire books at once. Imagine reading a novel and perfectly remembering every character and plot detail, then using that to answer complex questions. A large language model is an AI system trained on massive amounts of text data to understand and generate human like text, capable of various language tasks from translation to creative writing. Think of an LLM as having read millions of books and websites, learning patterns of human knowledge and communication. Claude 3's ability to solve complex math problems while explaining its thinking is like having a brilliant math professor available 24/7 who can not only solve problems but teach you how to solve them too. GPT, aka Generative Pre-trained Transformer, is a specific type of large language model architecture that's pre-trained on vast amounts of text data and can be fine-tuned for various language tasks. This is the technology behind ChatGPT and similar systems. The pre-trained part is crucial. It's like the AI has already completed general education and can now specialize in specific tasks. GPT-4's performance on professional exams shows just how powerful this approach is. It's mastering everything from legal knowledge to medical diagnosis. Tokenization is the process of breaking text into smaller units, tokens, that AI models can process, such as words, subwords, or characters. Think of this like breaking a long book into chapters, paragraphs, and sentences that are easier to understand. Anthropic's new method is exciting because it's like finding a more efficient way to package information using fewer tokens while understanding more. It's particularly impressive with technical language and non-English texts. The context window is the maximum amount of recent information an AI model can consider when processing or generating responses. Imagine trying to write a book summary while only being able to see one page at a time. That's the challenge of a limited context window. Claude 3's ability to handle 150,000 tokens is like being able to see and understand an entire book at once, making connections across hundreds of pages simultaneously. Prompt engineering is the art and science of crafting effective input instructions for AI models to achieve desired outputs and behaviors. This is like learning how to ask the right questions to get the best answers. Microsoft's framework shows why this matters. Better prompts mean better results with less back and forth. It's the difference between asking, "How's the weather?" and "Should I take an umbrella to downtown Seattle this afternoon?" Fine tuning is the process of adapting a pre trained AI model for specific tasks or domains by training it on additional specialized data. Think of this as taking a generally educated AI and giving it specialized training for a specific job. Meta's breakthrough is significant because it's like turning a general practitioner into a specialist with much less additional training. This makes creating specialized AI tools much more accessible. Foundation models are large AI models trained on vast amounts of data that serve as a base for creating more specialized AI applications through fine tuning or prompting. Think of a foundation model like a brilliant student who's completed a world class general education. Just as that student can quickly specialize in any field, these models can be adapted for specific tasks. Meta's breakthrough means businesses don't have to start from scratch anymore. It's like having a graduate student who can become an expert in any new field in just a few days. Multimodal AI systems are capable of processing and understanding multiple types of input simultaneously, similar to how humans process various sensory information. This is like giving AI all five senses at once. Just as you can watch a movie and understand both the dialogue and visual story simultaneously, multimodal AI can process different types of information together. Google's medical breakthrough shows why this matters. It's like having a doctor who can instantly connect what they see in an X ray with what they hear from the patient and read in lab reports. Zero shot learning is the ability of AI models to make predictions about categories or tasks they've never encountered during training, using only descriptions or related knowledge. Imagine meeting someone who can fix a new type of car just by understanding how similar cars work. That's zero shot learning. Claude 3's ability to identify new diseases without specific training is remarkable because it's like having a doctor who can diagnose conditions they've never seen before, just by understanding the underlying principles of medicine. Let me give you a simple prompt example of zero shot learning in action. If I ask an AI, "Classify this email as positive, negative, or neutral. Thank you for your terrible service and wasting my time yesterday." The AI can make the right classification without ever seeing examples of email sentiment before. It understands the task from the instruction alone. That's the power of zero shot learning. One shot learning is a machine learning approach where an AI model can learn to recognize new categories or perform new tasks after seeing just one example, mimicking humans' ability to learn from a single experience. Think about meeting someone new. You can recognize them again after seeing them just once. That's exactly what one shot learning enables AI to do. It's like the difference between a child who needs to see dozens of horses to recognize one and an adult who can identify a new animal species after seeing just one picture. Apple's breakthrough in facial recognition shows why this matters in our daily lives. Traditional systems needed multiple photos from different angles. It was like asking someone to do a photo shoot just to set up their phone. Now, just like how you can remember a face after one meeting, the AI needs just one photo while maintaining incredible accuracy. This isn't just convenient, it's also better for privacy since fewer personal images need to be stored. A simple way to understand this is through AI chat prompts. If I tell an AI, here's how to format names: John Smith, Smith, John. Now format Mary Johnson. It can learn the entire pattern from that single example. Few-shot learning is a machine learning approach where models can learn new tasks or categories from just a few examples, unlike traditional systems requiring thousands of examples. Think of a chef who can master a new recipe after seeing it made just once or twice. DeepMind's surgical achievement is incredible because it's like having a surgeon who can learn a new procedure by watching just 5 examples instead of practicing hundreds of times. This makes adapting to new situations much faster and more efficient. Let me show you what few-shot learning looks like in practice with a prompt. Imagine teaching AI to create themed business names. We might say, here are some coffee shop names: Daily Grind, a regular coffee shop; Been There, a coffee shop near tourist spots; Ground Control, a space-themed coffee shop. Now name a coffee shop near a beach. By showing these 3 examples, the AI learns the pattern of creating clever, themed names and can apply it to new situations. Transfer learning is a technique where knowledge learned in one task is applied to a different but related task, similar to how humans apply existing knowledge to new situations. This is exactly how humans learn. If you know how to ride a bicycle, you'll learn to ride a motorcycle faster. Microsoft's breakthrough shows the power of this approach. Imagine taking an experienced employee's knowledge and instantly transferring it to train new teams across different departments. It's making AI adoption much more practical and cost-effective. Reinforcement learning is a type of machine learning where AI agents learn optimal behaviors through trial and error, receiving rewards or penalties for their actions. Think of training a pet. You reward good behavior and discourage mistakes. That's reinforcement learning. OpenAI's data center achievement is fascinating because it's like having an extremely dedicated employee who experiments 24 hours a day and 7 days a week to find the most efficient way to cool servers, leading to massive energy savings. Generative AI systems are capable of creating new content such as images, text, music, or code based on patterns learned from training data. This is AI as a creative partner. Just as a human artist creates new artwork based on their experience and training, generative AI can create new content. Midjourney's breakthrough is remarkable. We've reached a point where AI can create images so realistic that even professional photographers can't tell they're AI generated. Diffusion models are a type of AI model that generates high-quality images by gradually denoising random patterns, creating increasingly refined versions of the desired output. Imagine starting with a blank canvas covered in random dots, then slowly revealing a beautiful painting by carefully removing the noise. That's how diffusion models work. Stable diffusion speed improvement is like going from having to wait hours for a painting to dry to having it ready almost instantly. Neural rendering is the process of using neural networks to create or modify visual content, combining traditional computer graphics with AI-powered generation. Think of this as giving AI the ability to be both a photographer and a CGI artist simultaneously. NVIDIA's breakthrough means we can now create photorealistic virtual worlds in real time. It's like having a movie production team that can create special effects instantly instead of spending months rendering them. Embeddings are mathematical representations of data in a high-dimensional space where similar items are closer together. Think of this as creating a giant virtual library where similar concepts are stored near each other. If cat and kitten are close together, while dog is slightly further away, the AI can understand their relationships. OpenAI's improvement means this library is now better organized and easier to search, leading to much better recommendations. Feature extraction is the process of identifying and selecting the most important characteristics from raw data that help AI models make accurate predictions or classifications. Think of this like being a detective who knows exactly which clues matter in solving a case. Instead of looking at everything, you focus on the key evidence. Google's breakthrough is like finding a way to solve cases with just the essential clues, making the whole process faster and more efficient while still getting the right answer. Batch processing is a method of processing data in groups rather than individual pieces, allowing AI systems to operate more efficiently by handling multiple inputs simultaneously. Imagine a chef preparing meals. It's much more efficient to cook multiple dishes at once than one at a time. AWS's achievement is like turning a small kitchen into a massive restaurant operation, handling a million orders simultaneously while actually reducing the cost per meal. Gradient descent is an optimization algorithm that helps AI models learn by iteratively adjusting their parameters to minimize errors, similar to finding the bottom of a valley by taking small steps downhill. Think of yourself trying to find the lowest point in a valley while blindfolded. You'd feel the ground around you and step in the direction that goes down. That's exactly what gradient descent does. Meta's improvement is like finding a faster way to reach the bottom while making fewer wrong steps along the way. Backpropagation is the primary algorithm for training neural networks, which calculates how much each part of the network contributed to its errors and adjusts accordingly. Imagine a company figuring out which departments are responsible for customer complaints and then making targeted improvements. Backpropagation does this for AI, and NVIDIA's breakthrough is like giving managers superpowers to instantly know what needs fixing and how to fix it. A loss function is a method for measuring how well an AI model is performing by calculating the difference between its predictions and the actual correct answers. Think of this as a teacher's grading system. Just as teachers need to measure how well students are learning, AI needs to measure how well it's performing. DeepMind's adaptive loss function is like creating a smarter grading system that helps students learn twice as fast. Optimization is the process of adjusting AI model parameters and architecture to improve performance, reduce resource usage, or achieve better results. This is like tuning a race car for peak performance while using less fuel. Microsoft's achievement is remarkable because they found a way to make AI run faster and cheaper across thousands of applications. It's like optimizing an entire fleet of vehicles simultaneously. Hyperparameters are configuration settings used to control the learning process of AI models, such as learning rate, batch size, and model architecture choices. Think of these as the knobs and dials you adjust when setting up an AI system. Just like a DJ adjusts different controls to get the perfect sound, we adjust hyperparameters to get the best AI performance. Google's automated system is like having an expert DJ who knows exactly which settings will work best. Cross-validation is a technique for assessing how well AI models will perform on new data by testing them on different subsets of the training data. This is like testing a student's understanding by giving them different types of problems, not just the ones they've practiced. Anthropic's method is exciting because it's much better at spotting when an AI might be learning the wrong things or developing biases. Regularization refers to techniques used to prevent AI models from becoming too complex or overly specialized to their training data, ensuring better performance on new data. Think of this as preventing a student from just memorizing answers instead of understanding concepts. OpenAI's system is like having a teaching method that ensures students truly understand the material while needing only half the study time. Dropout is a regularization technique that randomly deactivates some neurons during training, helping prevent over-reliance on any single feature and improving generalization. Imagine a basketball team that practices with different players sitting out randomly. This forces everyone to become well-rounded rather than relying too much on any one player. Meta's enhancement is like finding a better way to run these practice sessions, resulting in a stronger, more adaptable team. A convolutional neural network is a type of neural network specially designed for processing grid-like data such as images, inspired by how the human visual cortex works. Think of this as giving AI a visual system similar to how our own eyes and brain work together. When you look at a photo, you automatically notice edges, shapes, and objects. That's what CNNs do. Tesla's breakthrough means their cars can now process visual information as clearly as a human with eagle eye vision, even while moving at high speeds. A recurrent neural network is a neural network design that processes sequential data by maintaining a form of memory about previous inputs, making it ideal for tasks like text analysis. Imagine reading a book. You understand each new sentence in the context of previous ones. That's exactly what RNNs do. Google's achievement with simultaneous translation is like having a universal translator from science fiction that can understand and translate conversations in real time across 95 languages. LSTM is an advanced form of RNN that better manages long-term dependencies in sequential data, allowing AI to maintain context over longer sequences. Think of this as giving AI a better memory system. While a regular RNN is like remembering what someone said a few minutes ago, LSTM can maintain context from hours ago. Amazon's inventory system shows why this matters. It's like having a business expert who can spot patterns across months of data to predict exactly what customers will want. A GAN is a system where two neural networks compete against each other, one creating content and the other judging its authenticity to produce highly realistic outputs. Imagine an art student and a strict art teacher. The student keeps creating work while the teacher critiques it, making the student better over time. NVIDIA's virtual environment breakthrough is like having an artist who can create entire virtual worlds that look completely real, and they can do it in a fraction of the time it would take a human team. An autoencoder is a neural network architecture that learns to compress data into a compact representation and then reconstruct it, useful for dimensionality reduction and feature learning. Think of this like creating a highly efficient zip file for data. DeepMind's medical imaging breakthrough is incredible because it's like being able to compress a huge medical textbook into a small pamphlet without losing any crucial information. This means hospitals can share critical scans and images much faster. A vector database is a specialized database system designed to store and efficiently search through high-dimensional vector representations of data used in AI applications. Imagine a library where books are organized not just by genre or author, but by every concept they contain. Pinecone's achievement means we can now search through a trillion pieces of information as quickly as you can find a book on a shelf. It's revolutionizing how quickly AI can find relevant information. A knowledge graph is a structured representation of information that shows relationships between entities, enabling AI systems to understand complex connections in data. Think of this as a super advanced mind map that connects every piece of information to related concepts. Google's improvement means their search engine now better understands relationships between things. It's like having a librarian who not only knows every book, but understands how they're all connected to each other. Semantic search is a search method that understands the contextual meaning of search terms rather than just matching keywords, enabling more intelligent information retrieval. This is the difference between a friend who actually understands your question versus someone who just matches keywords. Microsoft's advancement means their search engine now truly understands what you're asking for, not just what you're typing. It's like having a research assistant who really gets what you're looking for. Text to speech is technology that converts written text into natural sounding spoken words, using AI to mimic human voice patterns and intonation. We've gone from robotic sounding computer voices to AI that speaks as naturally as humans do. Apple's breakthrough is amazing because it can now read text with proper emotion and emphasis in 45 languages. It's like having a skilled voice actor who can perform in dozens of languages. Speech to text is technology that converts spoken words into written text, using AI to accurately transcribe speech in real time across different accents and languages. Remember struggling to take notes in meetings? Google's system is like having the world's best secretary who can perfectly transcribe conversations even in noisy coffee shops and can do it in 30 different languages. The 99% accuracy rate means you can trust it to catch every important detail. Model architecture is the specific structure and organization of an AI model's components, including layers, connections, and processing units that determine how information flows through the system. Think of this like designing a building. Just as architects decide where to put rooms, walls, and corridors, AI architects design how information should flow through the system. DeepMind's breakthrough is like creating a building that uses 70% less energy while allowing people to move through it 3 times faster. Model compression refers to techniques used to reduce the size and computational requirements of AI models while maintaining their performance and accuracy. Imagine taking a huge library and somehow fitting it into a backpack without losing any books. Microsoft's achievement is exactly that dramatic. They figured out how to take AI models that needed a room full of computers and get them to run on a phone in your pocket. Quantization is the process of converting AI model parameters from high precision numbers to lower precision formats to reduce model size and increase inference speed. Think of this like converting a high resolution photo to a smaller file size while keeping it looking sharp. Google's breakthrough means AI models can now run on phones and small devices while staying almost as accurate as their full-sized versions. It's like getting IMAX quality on your smartphone. Pruning is the systematic removal of unnecessary connections or parameters in an AI model to reduce its size and improve efficiency without significant performance loss. This is exactly like pruning a tree, removing unnecessary branches to make it healthier and more efficient. Meta's achievement is remarkable because they found a way to remove 90% of the branches while keeping 95% of the tree's fruit. It's making advanced AI accessible to everyone. Inference is the process of using a trained AI model to make predictions or decisions on new data in real world applications. This is where the rubber meets the road. It's AI actually doing its job in the real world. Think of training versus inference like learning to cook versus actually running a restaurant. NVIDIA's breakthrough means their AI can now serve 100,000 customers simultaneously at half the previous cost. Latency is the time delay between sending input to an AI system and receiving its response, crucial for real-time applications. Think of latency as the delay between pressing a button and seeing the result. AWS's achievement of 10 millisecond response time is like reducing the delay between flipping a light switch and the light turning on to something so fast your brain can't even detect it. In healthcare, this speed can literally save lives. Throughput is the amount of data or number of tasks an AI system can process within a given time period, measuring overall system capacity. Imagine the difference between a single lane road and a multi lane highway. Throughput is about how much traffic can flow through. Intel's new chips are like adding 5 times more lanes while using less energy. It's revolutionizing what's possible in AI data centers. An API is a set of rules and protocols that allow different software applications to communicate with AI systems and access their capabilities. Think of APIs as universal translators that let different software systems talk to each other. OpenAI's new system is handling 1 trillion conversations a month. That's like enabling every person on Earth to have a conversation with AI 125 times each month, and doing it faster and cheaper than ever. Edge AI refers to AI systems that run on local devices rather than in the cloud, enabling faster processing and better privacy by keeping data on device. This is like having a genius expert built right into your device instead of having to make a phone call to consult them. Apple's breakthrough means your phone can now run sophisticated AI tasks without sending your data to the cloud. It's faster and keeps your information private. Cloud AI refers to AI systems and services hosted on remote servers, accessible via internet connection, offering scalable computing power for complex AI tasks. Think of this as having access to a massive supercomputer through the internet. Google Cloud's achievement means twice as many people can use these supercomputers simultaneously while paying 60% less. It's like making Einstein's brain available to everyone at a discount. Model monitoring is the continuous tracking of AI model performance, health, and behavior in production environments to ensure reliability and accuracy. Think of this like having a team of doctors constantly checking a patient's vital signs. Amazon's system is like having a medical monitor, so advanced it can predict and prevent nearly every possible health issue before it becomes serious. It's catching 99.9% of problems before users even notice them. Data drift is the gradual change in input data patterns over time that can cause AI models to become less accurate if not properly updated. Imagine a GPS system using outdated maps. It becomes less reliable as new roads are built and old ones change. Microsoft's system is like having maps that automatically update themselves when roads change. The 300% improvement in model longevity means AI systems stay accurate much longer. Model versioning is the practice of tracking different versions of AI models, including their parameters, training data, and performance metrics. This is like having a detailed family tree for every AI model, tracking its entire evolution and history. GitHub's breakthrough means companies can now manage thousands of AI models as easily as you manage different versions of a document, with the ability to instantly undo any changes that don't work. A/B testing is the process of comparing two or more versions of an AI model to determine which performs better in real-world conditions. Think of this like a cooking contest where chefs prepare different versions of the same dish to see which tastes better. Netflix's framework shows why this matters. By quickly testing different recommendation algorithms, they've made their suggestions 40% more accurate at finding what you'll want to watch. Ensemble learning is a technique that combines multiple AI models to produce better predictions than any single model could achieve alone. Imagine instead of asking one expert, you consult a panel of experts and take their collective wisdom. JP Morgan's system is like having 50 fraud detection experts working together in perfect harmony, achieving near perfect accuracy in spotting suspicious transactions. Bagging is a method that creates multiple versions of a model trained on different subsets of data, then combines their predictions to reduce errors. Think of this like asking different groups of people to solve the same puzzle, then combining their best insights. Twitter's success with content moderation shows how powerful this is. By combining multiple perspectives, they're catching harmful content more accurately while making fewer mistakes. Boosting is an ensemble technique that builds stronger models by repeatedly training new models to correct the errors of previous ones. Imagine a team where each new member specializes in handling the cases where previous members struggled. Salesforce's breakthrough shows how effective this is. Their sales predictions are now so accurate, they're helping businesses plan inventory with unprecedented precision. Decision trees are AI models that make decisions by following a tree like series of questions, breaking complex decisions into simpler choices. Think of this like playing a sophisticated game of 20 questions. Each answer leads to a more specific question until you reach a conclusion. Insurance companies are using these to transform their industry. What used to take days of processing can now be decided in minutes with better accuracy. Random forest is an ensemble learning method that combines multiple decision trees to create more accurate and stable predictions. Imagine instead of relying on one decision tree, you're consulting an entire forest of decision making trees and taking their collective wisdom. NASA's weather prediction improvement shows how powerful this is. They're now warning us about natural disasters with far greater accuracy. An SVM is a machine learning algorithm that finds the best boundary between different categories of data points in high dimensional space. Think of this like finding the perfect line to separate two groups in a crowded room, but in hundreds of dimensions instead of just two. The medical research breakthrough is incredible. It's helping doctors understand how different medications interact, potentially preventing dangerous drug combinations. Federated learning is a machine learning approach where models are trained across multiple devices or servers without exchanging raw data, preserving privacy while leveraging collective knowledge. Think of this like having study groups where everyone learns together but keeps their notes private. Apple's breakthrough with Siri shows how powerful this is. Millions of phones are helping Siri get smarter without ever sharing your personal conversations. It's like crowdsourcing knowledge while keeping everyone's secrets. Privacy preserving AI refers to technologies and methods that enable AI systems to learn and make predictions while protecting sensitive information and maintaining user privacy. Imagine doctors being able to study millions of patient cases without ever seeing actual patient records. Google's achievement in medical research is revolutionary. It's like having researchers work with invisible ink that only shows the patterns, not the personal details. This is accelerating medical breakthroughs while keeping patient information completely secure. Explainable AI systems are designed to make their decision making processes transparent and understandable to humans rather than operating as black boxes. Think of the difference between a judge who just announces a verdict and one who explains their reasoning. IBM's system is like having a transparent judge who can clearly explain every decision about loans, not just saying yes or no, but showing exactly how they reached that conclusion. This transparency builds trust. Model interpretability is the degree to which an AI system's decisions can be understood and traced by human observers, crucial for trust and accountability. Imagine having a detective who can show you every clue and explain every step in solving a case. Meta's breakthrough in content moderation means they can now trace exactly why any post was removed or flagged. It's like having a completely transparent decision making process where nothing is hidden. Bias mitigation involves techniques and practices used to identify and reduce unfair prejudices in AI systems' training data and decision making processes. This is like having a highly trained HR professional who ensures hiring decisions are based purely on merit. Microsoft's tool is remarkable because it's actively identifying and correcting hidden biases in hiring processes. It's making AI systems fairer while improving diversity, a win-win for everyone. Responsible AI is the practice of developing and deploying AI systems with consideration for ethics, fairness, transparency, and societal impact. Think of this as giving AI systems a strong moral compass. Anthropic's framework becoming the industry standard is like establishing a universal code of ethics that most major companies now follow. It's ensuring that as AI becomes more powerful, it remains aligned with human values. AI ethics is the study and implementation of moral principles and guidelines in the development and use of artificial intelligence systems. This is like creating a constitution for AI, establishing fundamental rights and wrongs. The EU's achievement in getting 90% compliance shows how seriously companies are taking these ethical guidelines. It's ensuring that AI development doesn't just focus on what we can do, but what we should do. AI governance refers to frameworks and practices for managing AI development and deployment to ensure compliance with legal, ethical, and performance standards. Think of this as creating traffic laws for AI, rules that ensure everything runs smoothly and safely. AWS's platform shows how effective good governance can be. It's like having a perfect traffic system where accidents are rare and everything moves faster. AI safety is the field focused on ensuring AI systems behave reliably, predictably, and in alignment with human values and intentions. Imagine having a super powerful tool with multiple safety locks built in. DeepMind's protocols are like having an incredibly sophisticated safety system that prevents accidents before they can happen, while still letting the AI do its job effectively. AI alignment is the process of ensuring AI systems' objectives and behaviors align with human values and intentions. Think of this as teaching AI to be a perfect team player who shares our goals and values. OpenAI's 95% human preference matching is remarkable. It's like having an assistant who not only understands what you want but also why you want it, ensuring their help aligns perfectly with your intentions. MLOps is the practice of standardizing and streamlining the machine learning lifecycle, including deployment, monitoring, and maintenance. Think of this as running a highly efficient factory, but for AI models. Google Cloud's achievement is like turning what used to be a handcrafted process, taking months into an automated assembly line that takes hours. It's making AI deployment as reliable as turning on your computer. Data ops refers to practices for improving the quality, speed, and reliability of data analytics and AI operations through automation and collaboration. Imagine having a perfectly organized kitchen where ingredients are always fresh and ready to use. Snowflake's system is like having a magical kitchen that preps all ingredients 80% faster while making sure they're 60% fresher. It's revolutionizing how we prepare data for AI to use. CI/CD for AI refers to continuous integration and continuous deployment practices adapted for AI systems, enabling rapid and reliable updates to AI models. This is like having a perfectly choreographed dance between development and deployment. GitHub's pipeline shows why this matters. It's like having a system that can update thousands of AI models simultaneously with almost no mistakes. Think of it as giving AI systems instant, reliable updates. A model registry is a centralized system for storing, tracking, and managing different versions of AI models throughout their lifecycle. Think of this as a library where every book remembers all its previous editions. Microsoft's system is incredible because it's like having a magical library where you can instantly revert any book to any previous version across 50,000 books simultaneously. It's making model management virtually foolproof. A feature store is a centralized repository for storing, managing, and serving machine learning features to ensure consistency across different models and applications. Imagine a central kitchen that supplies perfectly prepared ingredients to thousands of restaurants. Uber's breakthrough means AI developers can grab pre-prepared features like chefs grabbing pre-chopped ingredients. It's making AI development 70% faster while improving the final results. Data lineage is the documentation of data's origins, movements, and transformations throughout the AI development pipeline. This is like having a family tree for every piece of data. Amazon's system is remarkable because it's like having a perfect historian who can instantly tell you the complete history of any piece of information used in AI decisions. It's making AI auditing as easy as checking your email. Model serving refers to the system and infrastructure required to deploy AI models into production and make them available for use in applications. Think of this as a restaurant service system, but for AI. Netflix's achievement is like having a restaurant that can serve 10 million customers simultaneously, with each order prepared in less time than it takes to blink. It's making AI responses feel instantaneous. Pipeline orchestration is the automation and management of complex AI workflows, from data preparation to model deployment and monitoring. Imagine a symphony conductor, but for AI processes. Airflow's breakthrough is like having a perfect conductor who ensures thousands of musicians play in perfect harmony while using 70% less rehearsal time. It's making complex AI workflows run like clockwork. AI infrastructure refers to the hardware, software, and network resources required to develop, train, and deploy AI systems at scale. This is like having the entire physical foundation that powers AI, the roads, buildings, and power grids of the AI world. NVIDIA's achievement is remarkable because they've found a way to build this infrastructure at 20% of the cost while handling 5 times more work. It's making advanced AI more accessible than ever. AI lifecycle management is the comprehensive management of AI systems from conception through retirement, including development, deployment, monitoring, and updates. Think of this as caring for AI from cradle to grave, ensuring every system is born right, lives well, and retires gracefully. IBM's platform is revolutionary because it's like extending the healthy lifespan of AI systems by 300% while cutting their maintenance costs in half. And with that, we've completed our comprehensive journey through 100 essential AI terms. Each one represents a crucial piece of the AI puzzle, from basic concepts to cutting edge developments that are shaping our future.